Okay, here we go. Last couple problems here. 18. Expected sales of the theater snack bar. The Children's Theater found in a random survey that 58 customers bought one snack bar item. 49 bought 2 items, 31 bought 3 items, 4 bought 4 items, and 8 avoided the snack bar altogether. So, well, basically we have a table here, and I think there are 5 entries. And if we put that information into a table, if we have items, so we have 0, 1, 2, 3, 4. And so you got 8 people who avoided the snack bar. You've got 58 bought 1 item. 49 bought 2 items. 31 bought 3 items. And 4 bought 4 items. So if you add all those up, you'll get 8 plus 58 plus 49 plus 31 plus 4, 150. Did it say 100? It didn't say. Okay, so you have 150 total. So let's just, I should have added 1 extra row here, but so I'll just put an extra row in there. So the third row is going to be the probability of each one of these outcomes. So all we have to do is take this divided by 150 and get the answer. So you have 0.053. 58 divided by 150 is 0.386. 49 divided by 150 is 0.326. 31 divided by 150 is 0.206. And 4 divided by 150 is 0.026. Okay, so those are the probabilities. These are the outcomes. And what they say is use this information to find the expected number of snack bar items per customer. So all we have to do is the expected value is going to be equal to the value times the probabilities. And again, these probabilities should add up to be 1. All these added should add up to 1 if I did it correctly. And what I'm going to do actually is I'm going to rewrite these probabilities. I'm going to do them in terms of 8. So the denominator is actually, yeah, an easier way of doing this would be to do this. You take the numbers, each one of these occurrences. I'll explain here in a second once I get it all written out. That way I don't lose any accuracy in terms of rounding things off. So I'm just taking those numbers, and then what we'll do is we'll divide the whole thing by we'll take this whole thing and multiply by 1 over 150. And what that'll do is 8 divided by 150 is that. So it's just a way of calculating. So we take 1 times 58 plus 2 times 49 plus 3 times 31 plus 4 times 4, get 257 divided by 150, and I get 1.71. The book actually says 1.8. Round your number up to the nearest tenth. Make sure I haven't done anything wrong. So 58 bought 1, 49. Did I multiply by 58? Yeah, 58. 49. 31. 4. 0. Make sure I add them up. 8 plus 58 plus 49 plus 31 plus 4. 147. I don't know where I got 150 from. So actually all these will be slightly different. Anyway, so let me take my answer before and I'll just .7 .748, which we could still round up to 1.7. Okay, so that one's how that one works. Let's see, 19. Expected number of children to attend an amusement park. Amusement park consider adding some new attractions. Conducted a survey over several typical days and found that of 10,000 families, 1,020 brought just one child. 3,370 brought 2 children. 3,510 brought 3 children, etc., etc., etc. Find the expected number of children per family attending this thing. So it's kind of the same basic thing. What you would have is you take your expected value, which is 0, for nobody bringing any children. And it says it's 10,000, so we don't have to add those up. They should add up to. So we had 170 that didn't do any at all. So the probability is 170 over 10,000. Then you take the number of people that brought one child, which is 1,020. Again, divide by 10,000. This is the probability of bringing one child. Probability of bringing 2 children, 3,370 divided by 10,000. Then 3 children, 3,510 divided by 10,000. Brought 4 children, 1,340. 5 children, 510. And I'm dividing by 10,000 to get the probability of each one of these things occurring. 80 brought 6 children. And there go 7 children. Okay, so we have 0, 1, 2, 3, 4, 5, 6, and now we just need to do the calculation. This product will be 0. So I'm just going through multiplying these things out. You can do it too. Make sure you know how to do this. And I get 2.7. 2.668 to be exact, so I round it off to 2.7. It makes sense. Again, you've got, here you've got 3,002, you got 3,003. Those are the 2 high ones, and then they slope off on either side. So you'd expect the answer somewhere to, well, you'd expect to be between 2 and 3, just from a ballpark standpoint. And the final one is problem number 20. accepted sums of randomly selected numbers. 4 cards are numbered 1 through 4. One of these cards is chosen randomly without replacement, and the numbers of them are added. Find the expected value of the sum. Okay. So what you have is what we would do is we'd set up a table, and we're going to make it 5 by 5. And we're just going to take the cards. So we're going to have 2 cards, and the thing is, you can't have these are not going to work, because if you choose a 1, there's not going to be a 1 remaining. So if you choose a 1, then there's going to be 2, 3, and 4 remaining. The sums are going to be 3, 4, and 5. Likewise here, you're going to have 3, 5, 6. I'm just adding the numbers together. 4, 5, and 7, and 5, 6, and 7. So those are the numbers. So it's 3, 4, 5, 6, and 7. 3, 4, 5, 6, 7. So the probability of each one of these occurring is going to be the number of each occurrence. So there's 2 3s. How many sums do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the probability of this sum being 3 is 2/12, which is 1/6. The probability of getting 4, there's 2 4s. So 2/12 equals 1/6. Probability of getting 5, there are 4 cases where that happens. So that's going to be 1/3. There are 2 6s, so that's going to be 2 out of 12, which is a 6th. And there are 2 cases where it adds up to 7, so you get 1/6. If you add those up, you get 1. Okay, so now what we're going to do is we take these numbers and multiply by their corresponding probabilities and add them up. So the expected value, and actually the expected value should be 5 just because of the symmetry of the whole thing, and we'll show that it does work out that way. So you take the probability, well, let's put the value first. So you got a 3, the probability of getting a 3 is 1/6. You get a 4, probability of getting a 4 is 1/6. You get a 5, probability of 5 is 1/3. Then we have put parentheses around these to make it consistent. Then you got 6, and probability of getting a sum of 6 is that is 1/6, and then you have 7 times 1/6, and you add those numbers up. So and the answer is 5. So the expected value of this particular situation is a 5, because you take the individual probabilities, multiply by the values of each case, add the sum together, you get the answer.